Class, this is a video on how to calculate the efficiency of a machine. Efficiency is how much work is put into a machine versus how much work we can expect to get out of it. It is a percentage of how much work we can expect that a machine can give us. In a perfect world, it's always going to be 100%. We'll get the same work as we put in versus as we get out. However, the world isn't perfect and force can be lost due to friction or heat. And so we need to be able to figure out how much work we can expect from a machine. To do this, we're going to be using the formula efficiency equals work out divided by work in times 100. It'll give us a percentage. So for this question, calculate the efficiency of a machine that has an input work of 10 joules and an output work of 4 joules. We're going to plug in the data that we have. So work output was 4 joules, so E equals 4 joules, divided by our input work, which was 10 joules. And all that multiplied by 100%. So 4 divided by 10 is 0.4 times 100. So you move the decimal point over to the right 2 spaces to get 40%. When we put in 10 joules, when we put in 10 joules and only get out 4 joules, this machine is only 40% efficient, which is not really good machine at all, to be honest. We would prefer a machine to be more efficient so that we could get more of the work out of it. Now, often we know how efficient a machine can be, but we need to calculate how much work we get out of it. So this question down here is slightly different. Here they want us to calculate how much work a machine can output if it is 75% efficient and has 4 joules of work put into it. So here we know the machine is 75% efficient, but we want to calculate how much work we can expect from it if we put 4 joules of work into it. So we're going to be using the same equation, E equals work out divided by work in times 100. So here we have the efficiency. E would be 75 equals work out. Our input was 4 joules, so 4 times 100. In order to solve this equation, we need to isolate the variable that we're trying to solve for. So here we're trying to figure out what the work output is. In order to do that, I know you're learning this in algebra, so this should be a review. You need to do the opposite of what you do on this side of the equation. So, for example, here we're multiplying this side, the side with work, by 100%. To move that 100 over to the other side of the equation, we need to divide. So it would be 75 divided by 100 equals work out divided by 4 joules. See how we moved by doing the opposite thing? So 75 divided by 100 is the same as 0.75 equals work out divided by 4 joules. So now we still have 4 joules over on this side of the equation with our work out. So what we do is, since it's dividing, we do the opposite. 0.75 times 4 joules equals work out. Multiply that out, and this will give us 3 joules. So the machine that is 75% efficient, if we put 4 joules of work in, we can always expect to get 3 joules of work back out.